For almost all of human history, we lived under a ceiling, a beautiful, shimmering barrier we couldn't pass.
We built tools to look closer, observatories, telescopes, and then came Hubble. It didn't just break the ceiling, it showed us a universe far grander than we ever imagined.
But Hubble, for all its glory, had a fundamental limitation. It saw the universe in visible light, the same light we see. But the universe is expanding.
And the most ancient light in the cosmos, the light from the very first stars, the cosmic dawn, has been stretched as it traveled across the expanding universe. This is redshift. That ancient light shifts beyond the red our eyes can detect, deep into the infrared.
To see the beginning, we needed a new kind of eye, an eye that could see heat in the coldest depths of space. A machine of unprecedented ambition.
Enter the James Webb Space Telescope. Not just a successor to Hubble, but a complete reimagining of what a telescope could be.
The ambition was staggering. A primary mirror 6.5 meters across, too large to fit inside any existing rocket.
So they built it like origami. 18 segments made of beryllium, coated in a microscopically thin layer of gold designed to unfold far from home.
Why gold? It's the perfect reflector for infrared light. We built a golden eye to see the past. And because Webb sees heat, it has to be kept terrifyingly cold, minus 233 degrees Celsius. Any warmer, and its own heat would blind it.
That requires a sun shield the size of a tennis court. 5 layers of a material called kapton, each thinner than a human hair, stretched perfectly taut.
This wasn't like Hubble, which orbits Earth and could be repaired. Webb was heading 1,000,000 miles away to a gravitational balancing spot called L2.
It had to work perfectly. The first time. The complexity was terrifying. NASA identified 344 single points of failure.
If any one of them failed, the mission could be lost. A magnificent catastrophe floating uselessly in the dark.
Decades of work, $10 billion. The dreams of thousands of scientists.
All folded up and strapped to a controlled explosion. On Christmas Day 2021, the stakes couldn't have been higher.
Liftoff! The Ariane 5 rocket ignited, carrying Webb on a pillar of fire towards the void.
A perfect launch. But the easy part was over. Now began what NASA called the 29 days on the edge.
Webb had to unfold itself, piece by piece, 1,000,000 miles from help. And it had those 344 points of failure waiting. First, the solar array deployed, power. Then the communication antenna, contact. Small victories, but crucial.
Then came the sun shield. The most perilous part of the operation. If it snagged, if it tore, it was game over.
It relied on hundreds of motorized pulleys moving in perfect synchronization. In the control room at the Space Telescope Science Institute, the tension was agonizing.
Sun shield tensioning complete. The relief was palpable. They had built a shield against the sun.
Finally, the mirror. The wings unfolded and the 18 segments locked into place. The golden eye opened.
But it wasn't focused yet. It was seeing 18 different universes. The mirrors had to be aligned with nanometer precision, a process that took months.
When they finally focused it, The clarity was breathtaking. The alignment image alone was stunning.
July 12, 2022. The world waited for the first official images. We knew they would be good. We didn't know they would rewrite the textbooks.
Webb's first deep field, SMACS 0723. A patch of sky so small, it's like looking at a grain of sand held at arm's length.
And the universe revealed itself. It looks like a handful of jewels thrown onto black velvet.
Look closer. These arcs aren't stars. They are distant galaxies, their light stretched and distorted by the gravity of the cluster in the foreground. Gravitational lensing.
Hubble took weeks to capture its deep field. Webb captured this superior image in just 12 hours. The leap in capability was astonishing.
Then came the cosmic cliffs of the Carina Nebula, a stellar nursery sculpted by ultraviolet radiation and stellar winds.
Hubble saw a wall of dust. Webb saw through it, revealing the birth of stars hidden within. This is the power of infrared.
Stephan's Quintet, a cosmic dance of 5 galaxies, 4 of which are locked in a violent collision, revealing massive shockwaves.
In just its first few months, Webb transformed astronomy. Every image, a revelation. Every data packet, a revolution.
But the biggest surprises weren't just the beautiful images. They were the things lurking in the darkness that shouldn't have been there.
Webb found galaxies that were too big, too bright, too mature, too soon after the Big Bang. Galaxies like Glass Z13, existing just 300 million years after the beginning.
It's like finding a fully grown city in a place where only villages should exist. It fundamentally challenges our understanding of how the universe evolved.
The textbooks on cosmology are literally being rewritten. Our established theories are under scrutiny. And that, ironically, is a massive success for science.
But Webb isn't just looking at the past. It's looking for our future. It's looking for life. Webb uses a technique called transit spectroscopy. When a planet passes in front of its star, the starlight filters through its atmosphere.
It's looking for chemical fingerprints, the signatures of water, methane, carbon dioxide, the ingredients for life as we know it. It's already finding them on gas giants like WASP 39b.
We are on the verge of answering the biggest question in human history. Are we alone? And Webb might be the tool that gives us the answer.
It's a profound responsibility. Finding life elsewhere, even microbial life, would change everything.
The telescope is also a testament to human ingenuity and long-term cooperation. NASA, ESA, the Canadian Space Agency, coming together over decades to achieve the impossible.
We built a machine that can look back 13.5 billion years to the dawn of time, to witness the moment the lights turned on in the universe.
And in looking outward, we understand ourselves better. We are made of the elements forged in those stars. We are the universe trying to understand itself.
The golden eye doesn't just show us the cosmos. It acts as a mirror, reflecting the best of human curiosity and ambition.
Ever wonder why we explore? This is why.
salvation call.